Hi, my name is Gary Taylor. In his, what should we call it? I think we call it a lightning talk. I want to just do an introduction to Enzyme and tell you a little bit about what it is. It's a library for testing React. The React is the Facebook user interface stroke library that allows you to build user interfaces really quickly. And within that, because of the way that it's built, it also allows you to test it using test-driven code. We're able to run all the React lifecycle events that you would expect in a modern day spur or single page application. Things like it mounting, can it render, should it render, has it re-rendered. Lots of different frameworks have these lifecycle hooks, and we're able to hook into them. Um, and we're able to interact with the component itself. So on click, on mouse over, inputting of text boxes, we can do all of that. We're also able to update the state and props. Within React, you have the ability to store information within a placeholder called state. You can update it, and that information is then propagated out through the React components. Using Enzyme, we're able to actually update state, but actually we're not doing anything special. What we're doing is we're hitting the React events, which then update state, and then we're just testing that that state is in the state we want it to be in. We're also able to render the HTML and look at what the HTML looks like once it's been fully rendered. So, for instance, imagine a list of testimonials, stick some testimonials in there, output the HTML, and you should now have some elements with all your testimonials in them. Now, why should we choose Enzyme? Well, one of the things is it works with Jest, and I'm not going to get into Jest at the moment. I'll probably do another video on that. But basically, if you're not using Jest, you should be. It is awesome. So one of the core things about Enzyme is it works amazingly with Jest, and we should be using Jest. We're able to create tests in minutes, so that we don't have the problem of the lazy developer in the corner, the member of the team who lets you down. You go across and there's this new system, there's no tests, or worse, tests fail and he's committed the code anyway. There's no excuse for it these days with this system. We have the ability to utilize and share components. An enzyme helps you sleep. In other words, you can make sure that your React system is doing exactly what it should be doing, and you can do it quickly, which means that when you make a change, you run all your tests. If they're still working, then you can sleep at night. You know that you have done as much as you can do to get that out. There are many systems that have been designed that don't have any tests or have very limited tests. With Enzyme, React, and Jest, you really have no excuse. You can test the whole React component. Interaction, talked a little bit about that, button clicks, mouse overs, all your core React synthetic events can be tested. And we are close to the React ecosystem. We have the ability to get very close to it, almost as if you've created a browser and you're doing some tests that are using the browser. I can't think of one off the top of my head. There's quite a few of them, and it's a very simple API. Doesn't take a lot to learn. So here I've got a basic React app, uh, importing all the React goodness. And what I'm going to do is I'm going to import mount from the Enzyme. And mount allows us to get a React component and mount it into a variable, and it will run all of the lifecycle hooks. We can then grab the HTML that that component would have made, and we can use Jest's ability to go snapshot. So if that app changes in the future, this test will fail, and we now know that we've done something that affects app. This is a powerful test because it means that if you update something and you automatically see 6 or 7 other components failing, you know that you need to be very careful with that component because it's being reused in all of your apps. One of the powers of React is that you can reuse these things over and over and over again. But problem is that if you don't have decent tests, if you make a change to one React component, before you know it, you've broken lots of different apps. So we've got the wrapper. Here I want to simulate with a mouse click. It's very simple. It's very similar to jQuery where you do the ID. So bash button incrementer is the name of the button. That's the actual ID of it. I'm going to simulate a click, and I should expect the counter to be incremented. So the cool thing about this is that we can actually get the state out of our component and check it. So here I'm going to a counter, I'm getting the state out, I'm making sure it's equal to an object literal with counter equals 1. For some reason, I'm initializing the counter with a value of 1. Obviously, it should be 0, but I'm starting it at 1. And then on a click, I'm going to actually set that to 2. Someone comes along and fixes this and goes, your counter really should start at 0, my friend. He updates it in the counter, he runs the test, and all of a sudden these tests will fail. That's a good thing. That shows him that the developer actually did mean for that counter to start at 1. That's why he explicitly wrote that test. Go and find that developer or look through the documentation and find out why that counter started at 1. It could be that there's lots of code that's reliant on it, and by changing that, you're going to break more things in the system. Hopefully, other tests will also fail, showing you the compounded effect of making your one small logical change. Here I want to show you, I've got a testimonials container, which is just component, and it goes off, makes an AJAX call and gets a list of testimonials from an API call. So what I want to do is I've wrote a little setup routine that will go away, create that component and mount it, update it. What I'm doing is I'm resolving a promise here. This is a really quick, cheerful way of saying, do all the work, mount the component. Once you've mounted it and you've done all of the work, then return. But only return it once you've finished. Just to explain a little bit about what's going on here, we need to understand the way that JavaScript puts things onto the stack. Now, there is an amazing tool, I don't know the pronunciation, but I think it's Lupe, and it shows you how JavaScript has its core stack and how there's a stack related to either the browser or, in our case, Node, and how that's actually being called through. If I run the click, what we're doing here is we've got a mouse click, we've got a listener event, and that's being placed onto the browser's stack. Obviously, the JavaScript stack can't be listening to clicks on the browser, so that actually finds its way onto the browser's web API. So when that happens, we should go and produce this function which just logs, increment by 1, log this function, so just log to the console, and then increment. But what happens is whenever we have a timer, JavaScript's not able to actually run timers or set timeouts. Believe it or not, set timeout does not exist in the JavaScript language. It's actually part of the browser or Node. So what happens is that when it comes across this command, it will actually stick it in the web's API, and it will continue running this code. Once there's no more code to run, then the code within the stack will find its way back into the normal call stack. So if we do this, we can see that we got our click event, we increment a number, we put our message onto the stack, continue incrementing our values, and once all the work in the call stack has been done, then the actual event is fired, raised, the timer goes on, and now we do the console log. Now, the reason why that's so powerful is that what's happening here is the same. We are going to do all the work that's required to mount this component. Excuse me. Once we've done all that work, then we'll run this set timeout, which just so happens to resolve our promise, which basically means do everything you need to do. mount the component, render it, make an AJAX call, do everything that you need, the full call stack, and then return me the actual resolved wrapper. Here I'm just doing a mock-up. Fetch mock is awesome. It allows you to just mock any AJAX calls. And what we're doing here is on that URL, get that body. So here's our actual components testing. I've got some test data. I've got what I think the HTML will look like. I'm going to mock. I should really put the full URL in there, but just to be clear, any URL call will return this data. I now run and get my setup. So now wrapper has got everything. It's a fully mounted. Should component update has been run. Component did mount rather. It's gone off and made an AJAX call. Hopefully it's pulled this data back, and we can test that component did mount has been called. Excuse me, and it's true. We can go and get the data out of state and get a list of testimonials and make sure that it's equal to data, which it is. And then I can also make sure that the HTML is fine. And obviously there'd be more data here. I've just done the dots because I didn't want to type it all out. But we can see now that best product in the world has been come back from my testimonial. It's been rendered in, and we now have a fully testable AJAX rendered component. I hope you really liked this. Remember, guys, to hit that subscribe button. Check out the YouTube channel. You're probably already on it. This was supposed to be a presentation that I was doing for Stand Up. And check out the extra videos that I'll be doing on Enzyme. Hope you loved it. Cheers, guys.